Hello everyone, this is Dr. Sumit Chauhan and we are discussing data link layer. In this we have a video we have multiple access protocols. Now talking about multiple access protocols, we have three types: random access protocols, controlled access protocols, channelization protocols. Now when you talk about random access protocols, we have MA, CSMA, CSMA-CD, CSMA-CA. That is multiple access, carrier sense multiple access, collision detection, and collision avoidance. Controlled access protocols, we have reservation, polling, and token passing. And then we have finally channelization protocol. And in channelization protocol, we have FDMA, TDMA, and CDMA. In random access, a contention method, no station is superior to another station and none is assigned the control over another. No station permits or does not permit another station to send. The decision to send data depends on the state of the medium. In random access method, each station has the right to the medium without being controlled by any other system. However, if more than one station tries to send, there is an access conflict, collision, and the frames will be either destroyed or modified. Now in random access, we have multiple access, carrier sense multiple access, carrier sense multiple access collision detection, and carrier sense multiple access collision avoidance. Multiple access, then we have CSMA, and with CSMA we have two types: CSMA CD and CSMA CA. Now here we have Aloha network, we have multiple stations and one base station. The Aloha scheme was invented by Abramson in 1970 for a packet radio network connecting remote stations to a central computer and various data terminals at the campus of the University of Hawaii. It was designed for a radio, but it can be used on any shared medium. Users are allowed random access of the central computer through a common radio frequency band F1, and the computer center broadcasts all the received signals on a different frequency band F2. Pure Aloha. The original Aloha protocol is called Pure Aloha. The idea is that each station sends a frame whenever it has a frame to send. However, since there is only one channel to share, there is a possibility of collision between frames from different stations. We need to mention that even if one bit of a frame coexists on the channel with one bit from the another frame, there is collision and both will be destroyed. Now here we can see that we have four sender stations, and wherever there is an overlap represented as gray line, gray band, when there is an overlap between the data blocks of different channels, there will be a collision. The pure Aloha protocol relies on acknowledgement from the receiver. When a sender sends a frame, it expects the receiver to send an acknowledgement. If the acknowledgement does not arrive after a timeout period, the station assumes that the frame has been destroyed and resends the frame. The pure Aloha protocol relies on acknowledgement from the receiver. When a station sends a frame, it expects the receiver to send an acknowledgement, and if the acknowledgement does not arrive after a timeout period, the station assumes that the frame has been destroyed and resends the frame. A collision involves two or more stations. If all these stations try to resend their frames after the timeout, the frame will collide again. Pure Aloha indicates that when the timeout period passes, each station waits a random amount of time before resending its frame. The randomness will help avoid more collisions. We call this time the back off time. procedure for Aloha protocol. We have start, set back off to 0, send the frame. So this is a flow chart which shows Aloha protocol. The poor efficiency of the Aloha scheme can be attributed to the fact that nodes start transmission without paying any attention to what others are doing. This observation is the basis of the carrier sense multiple access protocol. Three variation in CSMA. One is one persistent CSMA, the another one is non-persistent CSMA, and then we have P persistent CSMA. Now this diagram is showcasing the persistent strategies. Now this is collision in CSMA that we have different senders and there is a collision. So we have a collision signal is also there. We have A frame and Z frame. Two frames were traveling on the same channel and they collide in between. So two more persistent strategies are non-persistent strategy and we have persistent strategy that either will wait for some time before sending again the data, or we don't wait, we simply sense the carrier, and if it's busy then we'll again sense the carrier. Our CSMA method does not specify the procedure following a collision. Carrier sense multiple access with collision detection augments the algorithm to handle the collision. In this method, a station monitors the medium after it sends a frame to see if the transmission was successful, and if so, the station is finished. If, however, there is a collision, the frame is sent again. CSMA-CD protocol can be considered as a refinement over the CSMA scheme. It has evolved to overcome one glaring inefficiency of CSMA. In CSMA scheme, when two packets collide, the channel remains unutilized for the entire duration of transmission time of both the packets. If the propagation time is small compared to the packet transmission time, wasted channel capacity can be considerable. This wastage of channel capacity can be reduced if the nodes continue to monitor the channel while transmitting a packet and immediately cease transmission when collision is detected. This refined scheme is known as carrier sensed multiple access with collision detection, or listen while talk. On the top of CSMA, the following rules are added to convert it into CSMA-CD. If a collision is detected during transmission of a packet, the node immediately ceases transmission and it transmits jamming signal for a brief duration to ensure that all stations know that collision has occurred. After transmitting the jamming signal, the node waits for a random amount of time and then transmission is resumed. CSMA-CD, the random delay ensures that the nodes which were involved in the collision are not likely to have a collision at the time of retransmissions. To achieve stability in the backoff scheme, a technique known as binary exponential backoff is used. A node will attempt to transmit repeatedly in the face of repeated collisions, but after each collision, the mean value of the random delay is doubled. After 15 retries, the unlucky packet is discarded and the node reports an error. Now this diagram shows the collision of the first bit in CSMA-CD. Now collision and abortion in CSMA-CD. This is the procedure that we have for CSMA-CD. Carrier sense multiple access with collision avoidance. In CSMA-CA, the IFS can also be used to define the priority of a station or a frame. In CSMA-CA, if the station finds the channel busy, it does not restart the timer of the contention window. It stops the timer and restarts it when the channel becomes idle. Now this is CSMA-CA procedures. How performance is improved in CSMA-CD protocol compared to CSMA protocol. Now in CSMS scheme, a station improved the channel before sending a packet. Whenever a collision is detected, it does not stop transmission, leading to some wastage of data. On the other hand, CSMS CD scheme, whenever a station detects a collision, it sends a jamming signal by which other stations comes to know that a collision occurs. As a result, wasting on wastage of time is reduced, leading to improvement in performance. Thanks for watching.